So the recorder is now on. I'm going to actually turn off the video so it's not quite as bad in terms of using bandwidth. And I'm going to start sharing my desktop. What I want to talk a little bit about today is I want to talk about penetration tests. And I want to talk about the process of a penetration test and how this kind of applies to your contest. Your contest is going to be a penetration test. It's going to be looking at how do I get into a system and figure out basically what's going on in that system, what's going on. Maybe I may ask you to pull out a particular piece of information that's on a system. I may ask you to do something even simpler. I may give you points for just identifying the operating system type that's in use by a system without being told what that particular operating system is. But in the real world, when we go out to do a penetration test, what we need to do is, number one, we always must get permission. Now this, I cannot stress enough. I taught you last time, the tools you're using in this class can be considered illegal if you use them in the wrong place. A penetration test is massively illegal if you don't get permission. In other words, there's different types of hackers. We talked a little bit about black hat and white hat. Black hat hackers are out there doing things for evil purposes. If you do a penetration test and you don't get permission, you're a black hat hacker, and you're going to be liable to anything that can be thrown at you, basically from a court of law. A white hat is a person working for a company that does penetration tests. And the neat things about these, last year I believe some of you, the instructors, may have been at the contest. There was a red team, and the military has red teams, and their job is to go out and perform penetration tests on the networks of the military. Now they have permission to do this. And there are different ways that penetration tests can be run. Some penetration tests are done with the full knowledge of the IT staff that a penetration test is taking place, and also with a knowledge of what's in the system already, so the penetration test company knows they're running Windows, got Cisco equipment, that type of thing. Then there are those types of penetration tests that are completely unknown. In other words, you don't even tell your IT staff. Now the CTO would know, probably the CEO would know, and that was it. That would be it. And that would be to test the ability of an IT staff to see an attack or an intrusion take place. Penetration tests are extremely important, and we're actually required at the college level to have a penetration test every year. For a couple years here on campus, we were able to use one of our ethical hacking classes, and our students were able to perform the penetration test on our college's network, and with the full permission of the Chief Technology Officer, and then perform a report and give that report to the main staff at Stanley Community College. Right, some interesting things happen, but one of the things that you need to do, and I just pulled up a quick, and this is not the be-all, end-all of the penetration testing steps. This is one of the first ones I found under Google. So, but this is one of the things that you need to look at is when you're going to have a penetration test, first get permission. Now, in our lab environment, you're welcome to do basically almost anything you want because the labs will reset themselves. So feel free to do that. In our contest, you will be given parameters of what you can and cannot do. For the most part, you are going to be in a pod that you will have full control over, and you're not going to have to worry about causing any major problems inside that pod. But we will have ground rules for you. In a true penetration test, you will have the same thing. Are you allowed, for instance, in a pen test, are you allowed to perform a scan or an attempted intrusion that could possibly bring the entire system down? For instance, are you allowed to perform denial of service attacks? That's a huge item on this planning and preparation, on this, what we call establishing the framework of the groundwork. And really, it's the rules of engagement. What are you allowed to do? All of that's going to be in the contract you have with the company you're doing the penetration test with. So I want to talk about it in that context because what we're doing in the lab I'm going to work on today with you and show you is we're doing many of the same things we would do inside of a penetration test. We're doing this second step here. We're doing reconnaissance. So when I drop you into your pod to do your contest, I may not give you any more information than the IP address range that is available on the network, and that's it. Or I may not even do that. I may ask you to look at the IP addresses that you are given and then figure out what addresses are available. Probably I'll give you the range, but just be aware, you're going to have to do some reconnaissance. You're going to need to go out there, and there may be a box sitting out there that you don't know what it is, that you don't have access to get to the console on it. You can't even open it up and look at it. Now, that's different than our labs because we can open up the boxes and we know what they are. But we need to look at some tools that will let us do reconnaissance. Then we're going to do that discovery. We're going to find all the items on the network. And once we've discovered them, done reconnaissance, discover them, found open ports, found what type of software is running on those machines, tried to figure out, does the machine have a vulnerable piece of software that we can exploit? All of those items we then take and go into our active intrusion attempt. So we're going to attempt to get into the system. And we'll show you that a little bit today too. And then we can go all the way through and do our report and analysis. What we're going to focus on today are reconnaissance tools. And I want you to be aware, there's two different types of reconnaissance. All right, we can do active reconnaissance, and we can do passive. Now, passive is going to be with a tool like Wireshark. Wireshark lets us sit out there, look at things going across the network, pull it off, and see what's going on. Another possible one would be TCP dump, which is they put some NICs in promiscuous mode, and then you can watch information going between different devices on a network. Those are passive. We're not actively going out and looking with those two. Now, our active tools are tools, and there are many of them out there, but it's a tool like Nmap, which we'll work with a little bit today, which can go out and scan a host, can scan a range, can scan individual ports, can do all different types of things to do scans. And then also another one is AMAP, and then there are just a multitude of tools that are out there. So remember, we're going to look at active and passive scanning. So first off, I'm going to go into the Ethical Hacking Pod in just our first lab, the one we looked at a little bit earlier last class. But I'm going to go in, and I'm going to pop up in the lab content, but I'm going to pop it over to another page because we don't really need it. And so we are sitting at the Kali box right here, all right? And we're going to look at and try to find information about, and we can do it on this OWASP BWA, which is a machine that was set up for us to actually attack, or we can even look over here on the OpenSUSE side and see what we can find here. But one of the first things I want you to be aware of is always, I've got Wireshark running here. Let me exit this. Always be aware that you can type nmap or man and then a command and get the manual page for this particular item, and it goes all the way through here. Or you can do what I did, which is a very easy thing to do too, and that is go and look at, well, I got to find the right page. Go find yourself the Nmap cheat sheet, okay? So you can go in and you can look at that. All right, hold on one second, folks. Sorry, folks. I thought that might be one of you trying to call in to get information about how to log in. It was another academy, so I'm sorry about that. But here's the Nmap where we can actually do a great deal of different things, such as scanning single host, scan a range of IPs. So let's imagine I give you something on the exam or on the test, and in the test, I ask you to figure out all the hosts on the 1.0 network. You could actually go in and go Nmap and then do 192.168.1.0/24, and it would go out and scan every single host on the /24, which if you've been looking at reading through your networking essentials and looking at our IP addressing like we talked about last time, that would be .1 through .255. Now, the only issue is, unless I'm mistaken, in our picture here, we don't have a 1.0. We've only got a 0.0. So that's where I would have to give you at least a little bit of information. So I'm actually going to stop this. So if you want to stop Nmap from running, hit Control-C, and it will stop the command. So we can go in here and we actually back it up and go, let's go 0.0 and scan. And now we'll go out and scan and look for every single host on this network right here. Okay? And so it should find .2, .100, and .254 eventually. And look at this, it did. It went out and it found .100, 254, and .2. So there they are. And it also showed you the services that are open on those machines. So we now know that on the 0.0/24 network, there are 2 live, or at least 3 live hosts, and those hosts have a variety of services that are open on them. Each one of them, at least the first 2, are running HTTP, and then on down through, we see some running HTTPS and SSH, and different various other shell connections and those types of things. We can see one running domain services, so DNS. Now, what do you think the problem is with running a scan like this, especially from a penetrations test standpoint? Anybody want to gather or make a guess at what might be a big problem? Well, let's do this. I'm gonna just type in. I'm gonna start Wireshark. It's a passive tool. Okay, so it is a passive tool, and I'm gonna have to. When you do run up Wireshark, you have to tell it what interface to capture on. So I go capture interfaces. In this case, there's only one interface on this particular Kali box, which is the 9.2, which is assigned to each 0. So I'm gonna click there and click Start, and you'll see there's nothing here at all. There's nothing going on. I'm gonna minimize this. And I'm going to go back over here and hit the up arrow, which you can always do that, repeat a command. And so I'm going to do that, and then I'm going to go back over here to Kali and take a peek. Look at all of this traffic that is being generated by that command. You'll look and see, if you go up here, look at everything, 9.2 going to 0.1, 0.2, 0.3, 0.4, ping request, nothing, nothing, nothing. Oh, there's a reply from 9.2. From 0.2 to 9.2, so we know that host is live, but then it has to go through every other host on that entire subnet. Look at it, all the way down to 255. And I'll scroll this, went over too quick there, but I'm going to scroll down, and you will see that it goes all the way through 255 eventually here as we go. That lab's been a little persnickety. So there they are, it's going on down through. And then it actually does all of them again and then runs through all the other tests. Now, here's the problem with this scan. Hey, it works great. It did exactly what I wanted it to. It showed me the live host on the 0.0/24 network. However, if someone was watching this with a network intrusion device, even a host intrusion device, if they were looking at it with some type of intrusion prevention system, this would have lit up their console like a Christmas tree. This is a very noisy scan that just goes out and looks for all those different machines on those particular ports. Now, the problem is, there's not an extremely easy way to scan an entire range quietly. Now, there are some different Nmap switches you can use to be a little more quiet, and also to do You can actually space out the scans to make the scans more stealthy, but you're still probably going to trigger some type of network intrusion detection with an Nmap scan. However, let's imagine that for some reason you got a single IP address. There's a couple ways that you could do a single IP address. One is, let's say we just for some reason knew that we wanted to scan the onion, or the not the onion, but the OAS box, which is 192.168.68.12. So we're wanting to scan it and just it. Well, what we could do there is we could do an Nmap, and we can do 192.168.68.12, and you'll see it scanned it. Okay, now let's do something real quickly. I want to go back. Okay, you see all this junk that was created here by this scan. I'm going to start a new capture. So I'm going to start a new one, and I'm going to continue without saving. I'm going to minimize this. I'm going to run this scan again. Now you'll see it still is going to create a decent amount of traffic, but nowhere near the amount of traffic it created before. It's only a couple pages here versus a page after page after page. So there are ways to minimize your scan. There's also, honestly though, in our contest, we're not going to do any type of points deduction for how loud or how noisy your scans are. So knowing the basics of how you can do these scans for our contest is not going to be a big deal. So you can just go out and do a big scan and find it. Notice that when we do these scans, one of the things that's happening is the information is being only displayed on the screen. So you need to capture it to output it to a text file if you want to actually save it. And you should be able to output it to a text file like this. And it's going to get, see, nothing goes there, to an ls, and you should see a test.txt. Then if I do a, maybe do vi test.txt, you can actually see the output of the scan in there. So you've actually got it saved in case you need to look it up later. So there are ways to output it too, and that's just piping it. And that, by the way, should have been a command you would have learned in the Linux Essentials course as you're going through those materials. You're just taking and running the command nmap against this IP address and outputting its information into a file called test.txt. So again, trying to make different things available. I'm going to ignore that phone call, folks. So other ways we could do things, let's imagine that for some reason we don't care about UDP on this particular machine. So I'm going to drag these over so because you're not really looking at them anyway. I'll put them back over here. Okay, so here's again your cheat sheet, Nmap cheat sheet. But we're going to go and we want to look just for a single port. So let's say for some reason I'm wanting to see if I can actually attack the port 80 on the Onion machine. So let's go 192.168. I always want to do 12. 68.12. Had it backwards. Oh, look. Okay. So in fact, port 80. Now, what is port 80? How do I know what that is, or what? Anybody? I don't think I muted you. I think you muted yourself. So if you want to unmute and talk to me, you're welcome to. Inside of our Networking Essentials courses that you've been working through, and probably in any of your courses you've had with your computer engineering and networking at your schools, you should learn that port 80 TCP is web traffic, or it's an HTTP server, Hypertext Transport Protocol. So I can, you know, if I want to be real stealthy and real quiet, instead of doing a full scan of the entire system like this, okay, instead of doing an Nmap and testing all the ports, I could be even stealthier. I could say, you know what, I'm going to do, I know for a fact that most machines and most of what I'm going to want to attack, I'm going to attack. Let's check port 80. Okay, so yeah, it's up. Now let's see how much traffic that created. Look, that didn't even create an entire page. Okay, well, one little page, but that's it. All right, so just barely created any information on its scan. And then I can say, well, I know now that that machine has an open web server. let's do this. Let's try port 22. 22 is open. Now, SSH is a way to remotely access a system. So I'm going to think, that's possible that I could maybe get into the system using that. And you'll look too, you'll notice, again, not a great, huge amount of information being picked up by anybody running a network intrusion detection system. I could keep going here. I could go, let's check port 53, which is DNS. DNS is closed, so it is not up. Now notice, be careful with this, because if you don't pay attention to what it comes back with, you can erroneously report that ports are open. This says state closed, so therefore 53 or TCP 53 is not open on this system. But now the other two are open. That means they responded. Okay. Let's try one more. Let's try 443, which is HTTPS. And it is open. So I'm fairly confident at this point that 68.12 is running a web server, because I've been able to go through and run tests to see that port 80 and port 443 are open. Now, I'm still not sure that what I want to do here in terms of how do I attack this box. What am I going to do here? Now, I'm going to try to do something. I'm going to try this, and I can run this against it, but it's an Nmap item, but we're going to try to do a script. We're going to try to pull the headers off of the equals HTTP dash title. Now, let's do headers. I want headers. Dash headers. And then we'll do 192.168.68.12. So we're looking at that. All right, now this is good news here. Let's look what we got here. Okay. So we ran a script to try to find out what kind of web server is running on this particular machine. And now when I run this, I ask it to go and find HTTP headers, and many times that header information will give you the type of server that's available. Pretty simple command, nmap -- script equals HTTP headers. By the way, straight off the cheat sheet, folks. So if you want to look at things on the cheat sheet that you could do, and this not saying anything, this might be a way to gather some points during the competition if you can correctly identify the version of Apache and those types of things running. But so we stay here and we look, and we can see that on this particular machine on .12 that this box is running Apache 2.2.14, and it's Ubuntu. Oh wow, that's even better. Guess what? I didn't even have to do an OS scan to figure out that this thing's now an Ubuntu box or some flavor of Ubuntu. Why is this so important? Why is this so such a great thing to be able to do? Anybody? Interaction. Let's go. You don't want me to have to turn the camera on and start dancing. It's ugly. I'm going to unmute y'all just in case, Jason. Any question? Any idea why it's a good thing to know? Nobody? Anybody there? Somebody respond with a word or something. Just say, hey.
Hey.
Okay, good. All right, good. We got something. So why is it good to know this? What can we use this for? Any idea? Okay. I'm gonna do something here. How many of you know about this thing called Google? There's this, I'm convinced there will eventually be a religion around Google, but let's go to the holy Google. And let's go and say known vulnerabilities, Apache 2.2.14. All right, so here we go. Here are the known vulnerabilities, and let's see, you think there's a couple of them? By the way, the higher score means it's worse. Here's one of 7.5, which is just about horrific. Okay, on down through. There's some vulnerabilities here. And then what you're going to learn as you move forward and continue to use the tools, especially under Kali Linux, you're going to learn about an application such as Metasploit, which may allow you to deliver payloads into a program such as Apache that has known vulnerabilities. So you've just figured out, as part of your reconnaissance, what version of Apache is running on the box you need to attack. In addition, as I scroll down here, you will see that there's 2214 still there. It's being used. You also see there's some Python in here and OpenSSL. So you got OpenSSL in here that's available. And you're going down, and you've also got Apache running on 8080. There's a proxy running Apache Coyote 1.1. And the 8081 is got Black Ice IceCap. But you can look and find via this one little command a great deal of information about the different programs that are on that box that you're then going to be able to attack later. So remember, we're all on the reconnaissance portion of what we're trying to do here. Now, there's another way to do this. We can also start, if you're looking less at services and more at trying to figure out what type of operating system the machine is running, especially if you're wanting to look at Windows boxes and others, you can actually do the -A, and this one is going to look and figure out, hey, yeah, DNS, it's not working, so it's okay. So DNS, we won't be able to look it up. And you go in and try to find all the different services and figure out what kind of operating systems in use. And in this case, it goes in and says, you know what, we think that this is a, we got to go all the way back up here. It pulls a lot of stuff up. Okay, so it goes in and says, Nmap looking at service, this is SSH. By the way, OpenSSH 531. All right, and then we could go and look and see if OpenSSH 531's got any known vulnerabilities to it. Here's Ubuntu, different methods, so you can look all the way through and see the different things running. 445 is NetBIOS Samba's running. On down, keep looking, keep looking. This is probably Linux 26X, and here's the kernel being run on it, so we can go and look to see if there's any known kernel vulnerabilities that we can exploit with this version of Linux. And then you got it to spit you out a NetBIOS name. And a NetBIOS name is the name associated with Samba or with Windows boxes. And this says OWA SPBWA, which is OWASP, and that is, if you're familiar with OWASP, it is a known program that's basically a broken web app. So they put a bunch of stuff on it that's broken so that you can go into it and attack it. One of the things I did in my penetration testing class is I gave them a series of Windows boxes, and one of the boxes had a known vulnerability that you could use to create a reverse connection to Netcat. Well, they were able to do that. Then they were able to use command line tools to create themselves a username and password with administrator access. Then they were able to actually own the box at that point and go in and find the files that I asked them for. They did that using this command here, using A. So you could go in and find out the different services that were running on the box. Now, you also have, you can do other things here. You have standard service and you have aggressive. So you can actually go in and do aggressive scanning. Now, if you want to see how much this creates, you'll notice that I'm going to stop this and start a new. If we run this scan, it's going to cause a pretty good amount of noise. So be aware of that. All right. Questions about Nmap? About anything dealing with Nmap? That's part of that first lab. Have any of you done this first lab? If you have, you can raise your hand. There's a little hand icon that you can do that right down at the bottom. And this is the first lab in the ethical hacking labs. Okay. Go back now and look. Once that thing's actually scanned, look at all the, see all the different amount of traffic it generated. So it generated a pretty good amount of traffic to do that scan. All right, so the other item we could use here, we could use AMAP. Okay. AMAP, just like Nmap, has a man page. Oops. You go on the man page and you can look at all the different mapping application. Just grab banners, do not send triggers. Okay, so we can try that one. So let's try AMAP dash B 192.168.68.12. Oop, wrong item. Oh, I'm a dummy. Sorry. Forgot to put the port number. This actually will go to specific ports. So it's going to grab banners on a specific port. So it's just going to look on port 80 in this case and did not get anything. So let's try lowercase b. It should be the same thing. Nope, there it goes. Actually went and pulled it. Here it is. I messed up. Capital B was just grab banners. Lowercase b prints ASCII banner responses. So we got to actually print it. So we see here, again, Apache 2214. Sometimes it's good to run some commands with two different tools so that you can get a better idea of what is actually going on and just verify that the two agree with each other. And they don't always do that, but it's not a bad idea to do that. So this is another tool that is available to you. Any questions about AMAP or Nmap? Now this, like I said to you, this is a lab inside of NetLabs. This is the first lab in our ethical hacking lab, Lab 01. So try to get that done sometime pretty soon, and you will be able to. Actually, we got somebody here now. Good. Somebody's playing with the pods now. You've got 15, I think it's 15 pods. You may have more of each one of these that's available for your groups to study with. So I'm going to close this, and I'm going to close this, and I'm going to go into a different lab because I want you to realize there are many different ways and different tools for you to use to study. The other one is, here is the Security Plus lab. And you will notice if you go in here, it's a little different setup. There's an external Kali box that's designed to be used to attack your networks. Here's the DMZ, the machine on it, and the internal Ubuntu. But if you look at the lab content, one of the things that this particular lab uses is a program called TCP dump. Now, I'm going to kind of skip around a little bit. I'm not going to do every bit of this, but I'm going to go into the Security Onion box, which is right here, and I'm going to open it up. And by the way, Security Onion is kind of like a Kali box, but it's used for management, for monitoring, log files, those types of things. A little bit different, but not much different than what you would see in your in a Kali Linux box. We're going to go in, and one of the first things I want you to do is use the command ifconfig-a to see the status of the links, and this shows you that you've got each 0 with an IP address of 10. So if we look here and kind of look at, so 10 should be over 1.6, excuse me, 1.6, which should be over here, over here. And then you've got the other one for the 10 network, which should be running, let's see, and it's not up and running with the second network. Actually, it is. It's just listening on the other side. Then they wanted you to check to see if the interfaces were in promiscuous mode. Now, let's talk a second about promiscuous mode versus non-promiscuous. Most NICs, most network interface cards, run in non-promiscuous mode, which means that they are not going to see anything not directed at them to the actual PC. So in other words, if something goes through the PC and it's not destined for the MAC address of that PC, it will drop that packet. You can see right here that these are actually running in promiscuous mode. You can also do it by running the command netstat-i, and then you can see that the B or the P means they're in promiscuous mode. So these NICs are in promiscuous mode. Now what's going to be kind of cool is you're going to be able to turn on TCP dump, and you're going to be able to see TCP dump grabbing echo requests and echo replies from this Kali Linux box to this Ubuntu box. So I'm going to go ahead and set up in here, the box, and actually it should already be set up. I'm going to do a continuous ping, which is going to ping. And in Linux, if you start a ping, it's continuous. It doesn't stop. So right now we got echo requests and echo replies flying out from Kali out to this Ubuntu box. Now typically the security onion wouldn't see it, but because it's in promiscuous mode, you can use a program called TCP dump. And TCP dump is a passive tool. And we actually have to do sudo. And sudo raises you up to administrator level. -I, eth0, and then ICMP. It's only going to look for ICMP. Now I got to find the password for this. And for the security onion, I got to go back up because I've got 5,000 passwords in my head. It is my password. So click back in here. MYPASSWRD. And I'm fairly certain I mistyped that. Nope. Yep, I believe it is. MYPASSWRD. WRD, not zero. Okay, so it's listening now. So what should happen in here in a second is it will start seeing, and it takes it a little bit, it'll start seeing those packets. I did this last time I did. It took a little bit to pick it up. There it goes. There we see them. Notice the echo request and echo replies. The echo request is from 203.0.110 or 113.2 going to, and I'm going to go ahead and stop this so I can, but you can see the echo request was from 203.0.113.2 going to 192.168.150, so going from the Kali box over to Ubuntu box, and then back to the Kali box with the reply. Now TCP dump, if you've got it sitting in between a network like this, can be used to grab information, any information traveling between those NICs, especially if you're set up in promiscuous mode. Now, quick question: how would I dump all this information if I wanted to capture this into a text file? Anybody know? Can I just do this? Can I just take it and say output this to, once I click in here correctly, output this to a file ICMP cap.txt. And then let's let it run a little bit, and then we will actually see. You also have the option, you can run a direct command with TCP dump to dump it into a capture file, and that's part of the lab too. This is a way you could do it without having to do that. Now it should have grabbed something at this point, so let's do that and do an ls, which is the list, and let's do I don't want to touch. Well, just do guys. Now you see we've captured all this information. All right, and we drop out. All right, so that's using the TCP dump features, or TCP dump, to dump the command, or dump the information out to a text file. And again, there is a way to do it using the built-in. You can actually go S0 and that basically dash right and then give it a name, capture pcap, and then you can set it however you want it to be, however big you want it to be. So files 100 in size. And then we'll actually dump it to capture pcap. The cool thing about pcap files is they can actually be opened inside of Wireshark. Oops. So if we go in here and we actually see, poop, hit the wrong thing. If I hit Control-C, do an ls, there should be pcap, ICMP cap, and there should be a capture.pcap. Now if I open another terminal window, and open Wireshark. I should be able to actually go File, Open, and we got to find where it went all the way out to the main. We'll copy it to the temp. Hold on a second, let me do the CP. Sorry. Brain poop. I've been inside of Windows too much. But you will find I am not the world's greatest Linux guru. That's something I'm still working on myself. But here we see the exact same file that we had from TCP dump, and we have saved it as a PCAP file, and the PCAP file is now available inside of Wireshark, and we can drill down and we can look at it in more detail in a graphical user interface. It's a little bit easier for most people to look at. It's also easier for most people to search, because we actually go and search and look for different packets inside of this particular tool. So that is one of the many things you can do with TCP dump, and there are others. There are a great deal of them, and they show you this in this lab. So I strongly recommend that you go and do this lab, which is the first lab in the Security Plus pod. Any questions on that? As we continue to move forward, I'm trying to give you a good overview of it. Well, let me actually stop this ping so I won't sit here and ping for the next 17 hours. Then we go down here into a Security Plus Lab 3, protocol and connecting to default ports. And in this particular lab, you have a pretty cool thing that you can do. And I'll be honest with you, I had to do some work to kind of get it to work correctly. Get Hydra to actually do the connection. But in this one, you open Security Onion and you do some captures, and you do some Nmap scans and find open ports. In this case, we're going to find out that on one of these machines, there's an open 150, by the way. There's an open port for Telnet. And then you're going to go in and use Hydra and a password list to break into that system. And then you're going to do some analysis and see that Telnet is sending clear text, which is terrible. And then go down and mitigate Telnet by 1. You're going to use your firewall to block any Telnet access, and that's what the pfSense will let you do. You're going to go in and actually create a rule that blocks all Telnet. Okay. So you're going to say, don't allow anything from the external interface that's TCP going from this network at all to the internal network using port 23. And this is where you've got to learn your port numbers so that you know that port 23 is Telnet. And once you say that, you will no longer be able to connect from the outside host into the inside host, because you've created right here a rule that doesn't allow any Telnet connections from the outside world in. And then they also show you how to use, when you do an Nmap scan, once that's done, you'll see that 23 TCP is closed on all the hosts inside. You're no longer able to see those because it's blocked by the pfSense firewall. By default, the pfSense firewall is not blocking much. All right. And then you've got the ability to use SSH. Now, SSH is Secure Shell, and it is a tool that allows remote access to devices using an encrypted channel. Now, what I'm going to do here is I'm going to just pull up this Kali box. Folks, I'm trying to keep our sessions to about an hour, so we've got about 10 minutes left, a little less. So I'm going to do this real quick. So I'm going to open up a terminal window, and I'm going to SSH to 192.168.1.50. And I got to come over here and get my password because I always forget. And there it is. So it's asking, what is the password to get into this box? Now, what went on in the background is it was actually being encrypted so that it could not be seen. And that's what the live has you do. It actually has you go in and do that particular Wireshark capture so you can see that it's going in as an encrypted entry. And now, guess what? I'm now logged into the Ubuntu box remotely using SSH. And anything that's sent between me and that box. Now let's do that. Let's go ahead and open another box here and do Wireshark. Okay. And okay, that'll be fine. If not, I can sudo it. All right, let's do this. Open that again. Sudo Wireshark. Oh, okay, I was already sudoed. That's why it's doing it to me. So I got to do capture interfaces. Let's do E0. Start it. So now it's capturing some things here, some ARP requests and all. But if I go, I'm connected. I'm going back to here, not there. Back to here. I'm doing LS. Okay, and I'm gonna do LS dash LA. There we can see I'm looking at all the root. Okay, looking at different things here. You'll notice if you look back over here, you'll see the traffic's SSH, and look at it. They're encrypted packets going between 1.50 and 113.2. So those packets are encrypted, and you're not able to see into the devices. Question, I see two questions here. Sarah's talking about, is this reconnaissance? Yep, we're doing the reconnaissance labs, and we've been looking at Nmap, AMAP. We looked at Wireshark. We've looked at TCP dump, all those parts. And the answer to will they be able to use a cheat sheet, the answer is no. Okay. Now, here's the thing. The man pages are built in. So you don't have to memorize everything. You just have to be able to know how to do man Nmap, and then how to get in here and kind of read through these. If you don't remember something, the information will be there. All right, but we're not going to allow the use of a cheat sheet at this point. That's our plan anyway. So that's why we're teaching you how to use the man pages. So if you can't have to, you can use that. Remember, again, one of the big things we're doing, we're not going to penalize you for being super wordy, not wordy, but super loud with your scans. So the ability to drill down very, very deeply will be an advantage if you learn those commands and commit them to memory, because then you won't have to go through the man pages and find those commands, and you won't have to dig through a huge amount of information that would come from a wordy or a loud scan. So the advantage would be if you do memorize the very detailed commands needed to pull out one piece of information, you'll get that information faster, and you will probably be able to complete more tasks for the competition. All right. Are there any questions so far about what we've been going over? About reconnaissance? About the use of Nmap, AMAP? Remember, go get your cheat sheet, print it out, play with it, commit it to memory. You know how to do a single port scan, know how to do Nmap-P, and then -22, 80, 53, 23 for Telnet. Be able to do those so you can go and do a quick scan of each one of those. Now these scans, these are used to do connect scans. This gets a little more detailed into what Nmap can do. We can actually go through and look at different types of scans, like a connect scan, which goes through the entire send, SYN-ACK, and ACK process, and a send scan, which sends a send, expects an ACK back, or SYN-ACK back, but never sends an ACK. And also you've got the ability to scan just UDP ports if you want to do so. So again, some of these scans require that ping is allowed through, some don't. So down the road, as you learn more about Nmap, you can get into the point of you're just scanning for certain ports and certain types of scans. And then AMAP, you can go through and look at the different things AMAP's available to do too. Okay, folks, I'm going to stop sharing my desktop. I am going to stop the recording, and you will be able to give me any questions that you may have. So I'm going to stop the recording.